There is so much information you can extrapolate from a temperature-energy graph. As an example, I will show you what a typical graph for water looks like, starting from below its freezing point. Below 0 degrees Celsius, water is a solid, it's ice. Let's say I have a freezer that can go down to minus 40 degrees Celsius in temperature. When I take an ice cube out of the freezer, my ice cube will also be at minus 40 degrees Celsius. If I begin transferring energy to my ice cube using a Bunsen burner, its temperature will increase, but only until it reaches its melting point, which is 0 degrees Celsius. This horizontal line shows us that even as we continue giving energy to this ice cube, its temperature remains the same. That's because the ice cube is using all of this energy to change its state, to melt. And while it is changing state, it does not use any of the energy to increase its temperature. When this ice cube melts, it changes into a liquid, which is represented by this whole region of the graph. The slope here shows us that the energy is being used to raise the water's temperature. When it reaches its boiling point at 100 degrees Celsius, again, temperature does not increase with energy. All of the energy from the Bunsen burner is used to evaporate the liquid into a gas. To summarize the features of a temperature-energy graph, a slope shows that energy is being used to raise its temperature. But when a substance changes its state, all of the energy is used to change its state such that its temperature remains constant, and this is represented by a horizontal line.